Welcome back. Before we get started on our first project, let's take a quick look at the MIT's G-code editor. The first section is the viewing screen. It is almost a complete representation of the software on the wire machine. The big difference is that we have added a lot more flexibility. With the toolbar at the top, we have our control icons for the viewing screen, information boxes displaying our program coordinate system, mouse locations, and information related to other icons. Our first set of icons is the motion control for our program file. Reset and run with the options of fast and slow. Then we have step forward, which is used to step the code forward one line at a time, or step back, to step the code backwards one line at a time. To give you examples of these icons, we will first reset the code by pressing Reset, and using the Run icon, we can run the code. A nice option we have added is the breakpoint. Find a location in the code where you want to stop. Highlight part of the line or all of it using your right mouse button and set a breakpoint. Now use the Reset icon and run the file. You can see that we stopped right at the line of code which we set our breakpoint at. We can now examine the code by stepping forward or backwards as much as we wish. To remove the breakpoints, use your right mouse button and select Clear Breakpoints and press Run. The next set of icons is the screen controls. The first one resets your mouse pointer. The second is Zoom Window. Then we have Zoomed Previous. Now we have the small hand symbol, which allows you to move the whole screen around. The last icon allows you to zoom to Object Extents or to Table Extents. The next group of icons is Rotate, Animation, and Show and Hide Graphics. Rotate is used to rotate the image on the screen, which we will use to demonstrate the Show and Hide Graphics button. Turn on Program Path Z5. Show and Hide Graphics turns on and off the different features of the objects. Animation will rotate the image automatically in a predetermined sequence. To turn off animation, press the animation button again. To return to top view, use your right mouse button and select Views, 2D Top. At this point, we should make a note that in this video, we have been using the mouse wheel to zoom in and out, and not the zoom window feature. The last group of icons is Measure Distance between 2 points, Draw Lines, and Toggle Snap On or Off. With Toggle Snap On, if you turn on this button, it will highlight the corresponding lines of code in the editor when you move your mouse around the object vertices. In the Editor section, we have a text editor, which allows you to edit your G-code live, and by using the Step Forward and Step Backward buttons, you can watch your graphics update as you change your G-code. We have also added tooltips to the editor. If you place your mouse over the different codes, it will show you a tooltip explaining what that item is. Tooltips can be turned off by pressing the tooltip button again. On the left is the Mitsubishi numbering system, consisting of the L number, which is the program number, and N number, which is the sequence or subroutine number, and the B number, which is the block number. This numbering system helps you better utilize the power and capabilities of the Mitsubishi EDM wire machine, allowing you to build extremely complex files, which is very difficult or even impossible when you use an N number on each line. The numbering system window can be closed with this icon. Please be aware that any hand editing that may be necessary is done in the View section code editor. The code window in the Code Generator section is read-only. The Code Generator section will be well covered in the tutorial. Let us show you our first project. In this video, we are going to build a complete project with 17 die cavities in one die block. This will include 4 pilot holes with a coreless cut, a rough cut, and 1 skim. 3 punch holes with a coreless cut, a rough cut with a 2-degree taper, and a 0.1-inch land with 3 skims. 4 L-shaped holes with a rough cut and a 1-degree taper, including a micro joint and a 0.1-inch land with 3 skims. 4 T-shaped holes with a coreless cut, a rough cut with a 0.5-degree taper, and a 0.1-inch land. 2 C-shaped holes, rough cut with a 1-degree taper, a micro joint, and a 0.1-inch land with 3 skims. This will be accomplished in 3 passes. Pass 1 will include the 4 pilot holes to completion, the 3 punch holes to completion, the 4 L-shaped holes up to the micro joint, the 4 T-shaped holes to completion, and the 2 C-shaped holes up to the micro joint. Pass 2 will include cutting off the 4 micro joints in the L-shaped and 2 in the C-shaped holes, and dropping the slugs. Pass 3 will include finishing off the land cuts with 3 skims on the L-shaped and C-shaped holes. Let's take a quick look at the final result before we get started, and then Jim is going to take you through a tutorial on building this project.
To start, we will go up to the generator tool, start it, choose a customer, either new or existing. We will take an existing customer. We will give it a project name, new, and we'll call it BananaPlug. And we'll say OK. We will set it for steel, standard, 10 thou wire, brass, and 1/2 inch. And we'll make sure that our taper Z is set at the exact height of our metal, which is 1/2 inch. Next, we will then go and load a DXF file. We will select all the objects that were available to us in the DXF file. We will create objects. And we're finished. They are now displayed in the object list. We will turn them all on, and they will regenerate, and we will zoom in all of our objects. What we're trying to do is create the first 4 as the one set, the next 3 as the second set, the L-shaped items as the third set, the T-shaped items as the fourth set, and the 2 C's as the fifth set. So let's go find the first ones. And if we move our mouse over the locations, we will come across them. First of all, we take off the outline object and we will give it a new name. We will call it R0.06 and save. Our anchor point, intersection point, and wire insert are automatic on a circle. To change them, you pick points. We will change the offset. Green is your offset line, your purple is your program line or your metal. We will give it 1 skim. This is a pilot hole, so we're no need for lands, and we'll do a coreless on it. We'll build it to take a look, and we will quickly look at it in 3D, and there it is. And we'll go back to our object list. So we've done our first one. What we now want to do is create the 4 holes. We'll go to the locations. We will add a new location. We will set on there. Next one, there, and our 4th one. Our 4 holes are now set. We're after this guy now. And there it is. We will check the outline objects. We will rename it as R0.058. Save. We'll give it an offset of a right hand. And in this case, we want to give it a taper of 2.0. We want to give it a coreless, and we want to give it land. Our land height is 0.4 inches. And we will give it 3 skims on the land. And build. We will view it. That is correct. Our coreless is a straight up and down cylinder, but the distance between the bottom is negligible, so our rough cut on our cylinder will take care of that. Object list. We will have to add these 2 circles to their locations. Okay. We're now looking for the 4 L-shaped ones. We will go after the first one. Here it is. Unclick the outline. Change the name to L shape. Save. This time we have to give it the anchor point, intersection point, and wire point. Our anchor point that we have chosen is this point right here. Our intersection point is the center of the bottom line. And our distance to our M20 in this case is 0.05. And then we will click upwards. We can either click on either direction also, or the bottom, or straight down. In this case, finish. We will give it a micro joint. We will give it a taper angle of 1.0. We will give it a land of 0.4 inches. And we will give it 3 skims. And that's okay. We will then build it. Missing our offset. Give it a right hand offset and we will try again. There it is. When we set a taper, we must make sure that we do not cause problems at the bottom in case it's too large. We can view this one. We'll go back to our object list and we will add the next 3 into it. As you can see, we have to mirror the first one on the x-axis, a second one on our y-axis, and we have to mirror the third one on x and y. Our first one on the x, second one on the y, third one x and y. And now we're after the 4 T-shaped figures. We'll go and locate the first one. There it is. We will unclick the outline object. We will give it a new name of T-shape. Save. Set our anchor point, top dead center. We will give our intersection point the same, and our M20 distance we'll give as 0.4 and specify. Next. In this case, we're going to be doing a 0.5 inch taper, and we will do coreless. And we will do a land, again 0.4 inches, and we will give 3 skims, 0.4 inches. And we will build. We have not set an offset. Right hand, and that's what we're looking for. Just to give it a quick check. Yes, that's correct. And we will add our other 4 ones. Top dead center, second one, bottom dead center, and our third one, bottom dead center. These 2 here, we'll show you. They have to be mirrored. Okay. So we will mirror them in the Y. Correct. And our 2 C-shaped items, we'll find them. Turn off the outline, rename it C shape, save. We will set our anchor point at this point, our intersection point, the middle of this line, and our distance on this one is 0.035. And we will set it, finish, and we will give this one a 1 degree taper, and we will give it a land and a microjoint, a land of 3 skims and 0.4 inches. Build. Again, we forgot the offset. This is correct. Quick view. Is that what we want? Yes. And we will set up the second one. Add. Right to there. Okay. And as you can see, we have to mirror this one in the Y. Mirror it in the Y. We say okay. Now we can generate our G code and take a look. And that's it. And we'll take a quick look this way. And there we are. Finished. We can then go and save as. Demo 2 and save. We're done.